Welcome back. For the past few months I've been trying to do what many people have said is impossible, get Mario 64 running on the Game Boy Advance, a console massively underpowered when compared to the N64. Let's compare the two. The N64 has a fully 3D capable graphics processor called the Reality Signal Processor. It's capable of vertex transformation and projection, perspective correct texture mapping, and much more. Everything you'd expect from a fixed function graphics chip. The GBA, in comparison, has only a simple picture processing unit capable of drawing 2D sprites to the screen. It's definitely not to be sniffed at and was quite advanced for its time, but sadly all of this counts for exactly nothing because it's got no capabilities that are useful for rendering 3D graphics. The best we can use it for is drawing the HUD on top of everything else, which is hardly an impressive feat. This means that if we want to do 3D graphics on the GBA, we have to render everything out, pixel by pixel, with the CPU alone. When doing geometry calculations such as tracking the position and velocity of entities, polygon vertices and much more, floating point numbers are the gold standard. But here things get even more dire. Where the N64 had full support for single and double precision floats, the GBA has no floating point support at all, and is only capable of relatively simple integer operations. Even here though, it falls short. The GBA has no native support for integer division, which means we've got to emulate it using software tricks. Clock speed is an issue too. While the N64 has a whole 94 MHz to offer, the Game Boy Advance has to make do with just 17. This isn't a perfect comparison because clock speed doesn't necessarily translate well to data processing speeds. Many people have argued in the past that the N64 was not a true 64-bit console because it has a 32-bit memory bus. There is no single definition of what 64-bit means, but if you take this to be true, then by the same metric, the GBA is largely a 16-bit machine. The game ROM and most of the RAM sits on the other end of a 16-bit data bus, which means that pulling 32-bit values requires two memory fetch operations, not one. This places fairly severe constraints on the way game data must be organized in memory to avoid performance problems. Lastly, sheer memory capacity is an issue. Where the N64 had a juicy 4 megabytes of RAM, the GBA has only 288 kilobytes, almost 15 times less. As mentioned, about 90% of that sits on the other end of the 16-bit memory bus, so is subject to the same harsh access penalties, 32-bit values, as ROM data. Hopefully that gives you an idea of the challenging nature of this project. With that said and done, let's get into the recent changes. When writing games, we face the problem of needing to store data about game objects that might differ in various ways. For example, Mario and a coin might share certain attributes like position, a shadow, and, at least in some cases, influenced by gravity, but they differ in many others. Mario can jump, walk through doors, collect stars, and long jump. They say that money talks, but the ability to BLJ through to the next parallel universe might seem somewhat off the cards for a lowly coin, and so the system needs to be able to represent this fact. Solving this takes many approaches, but the one I've landed on is that of an ECS. In an ECS, each meaningful property of an object, called a component, gets stored in a data structure specific to that component. Entities then simply hold optional references to indices within these component data structures. This means that all data pertaining to these components, for example Mario's movement state, can be optionally applied to each entity as and when required. To manipulate the state stored by the components, we use a system, a glorified function that has the ability to iterate over entities that possess a subset of those components, allowing us to implement behaviors that relate only to specific kinds of entities without requiring a lot of branching logic to handle all cases that may arise. Given the performance and memory limitations of the GBA, I've chosen to implement this ECS from the ground up myself with an eye to keeping memory usage low and placing performance-critical data in the much faster onboard working RAM that the GBA has, instead of the comparatively slower external working RAM. As of this update, what few objects there are in the game, like Mario, doors, stars, and this coin, are managed by the ECS, allowing for flexible spawning of new entities as required for each stage. During the transition to the ECS, I ended up redesigning the way stage transitions work. I took this opportunity to add a portal wipe effect similar to the original game, and I should note for Nintendo's lawyers, extremely similar to those seen in many older forms of media too. It's a small detail, but it really adds to the experience of moving through the game. Incidentally, you might have noticed the new idle animations. Somebody mentioned the lack of idle animations in the comments of the previous video. Good suggestion, I don't recall who you are, I'm sorry. The shadow under Mario, and indeed all shadows, are now translucent. This is more difficult than it might seem on the GBA hardware. Using the GBA's true color bitmap modes, each color is represented as a 15-bit number, so decoding and encoding the color in order to manipulate it ends up being extremely expensive when added to the inner loop of the rasterizer. That said, since I'm using the GBA's paletted bitmap mode, this problem becomes a lot easier. I simply pre-compute a lookup table at build time that maps each index in the palette into another slightly darker index in the palette, and then perform this comparatively fast lookup in the rasterizer's inner loop. The result? Flat color transparency drawn quickly on top of any surface, and no slower than plain old texture mapping. This will come in useful later given that Super Mario 64 contains a lot of transparent surfaces. In the original game, water is a common gameplay element, so why should playing on the Game Boy Advance be any different? Since the last video, I've implemented water surfaces and swimming mechanics. Using the palette lookup table trick I mentioned before, we can tint triangles that appear on the other side of the water plane to the camera blue with relatively little expense. When the camera is immersed in water, we can even change out the entire palette to add a tint to everything in the scene. There's more to be done here. In particular, entities below or partially below the water should be tinted too, and this isn't done yet. Additionally, moving water surfaces will prove a challenge to implement. Swimming movement was quite fun to work on. The player's motion feels very fluid and it acts as a good demonstration that the engine is capable of full 3D camera movement, and not just a fixed perspective trick. I briefly showed them off in another video, but several characters now have been added to the game. Thanks to @LarryCooper, DS Hacker and Pack64 for contributing models and animations to the project. I'm not entirely sure exactly how alternative characters might fit into the project, but at least it's nice to see that the engine has no trouble supporting them. A big change made after the last video has been the addition of material attributes. Briefly, this allows the surfaces in the world to be tagged with specific non-visual properties, allowing the engine to treat them differently. For example, it's possible to tag a surface as slippery, a slide, or even animated. These attributes can be specified from within the model itself, making level design easier. As the project progresses, I'll be adding more attributes to allow for more behaviors. Mario now has more movement options, bringing the project closer to the original game. He can now shimmy along walls and slide down slopes. In previous iterations of the project, collision detection was a major source of bugs. Collisions with walls were jittery and imprecise, and it was possible to push through walls with enough speed, or in places with awkward geometry, like tight corners. Since then, I've rewritten the collision code from scratch, fixing almost every existing bug. Movement is now smooth and deals with low tick rates extremely well. Even speeding up the game to 4 times its usual speed doesn't result in significant problems. Previously, billboards, that is to say a flat surface drawn into the world always facing the camera, used the same rendering code as polygons. This was needlessly inefficient and resulted in visual problems. The billboard rendering code has now been rewritten entirely as its own distinct subsystem, meaning that billboards look better and can deal with variably sized textures and render much faster. As a result, it's now possible to display many trees in the castle grounds without a significant performance problem. I'm sure you'll have already noticed the addition of particles. The dust that appears around Mario's feet when sliding or landing on the ground is drawing in a similar way to billboards. There's not too much to say about them, other than that I'm enjoying the visual flair they add to the game. The old PlayStation 1 style graphics have now been one-upped by the implementation of sub-pixel precision. Previously, polygon vertices were snapped to the pixel grid before rasterization. This no longer happens, and the rasterizer is able to account for differences when drawing polygon edges and performing texture mapping. This results in cleaner and smoother visuals, which is particularly relevant given the low resolution of the screen. Last of all, the bit you've been waiting for. I've started work implementing terrain-like entities. They're not particularly well optimized yet, but they do work and they're great fun. Mario's coordinates get translated into the coordinate space of the entity, collision resolution gets applied just like regular terrain, and then Mario gets translated back into world space. All of these new changes have been a drag on performance, unfortunately. To compensate, I've had to squeeze every last CPU cycle out of the existing code. Right now, performance is no worse than the last video, even though there have been a lot of new changes. I'm hoping that can remain the case in the future, but adding entities and other objects to the game is going to be a challenge. I'd like to thank @LarryCooperDSHacker, @Smallbug, and @Pack64, all of whom have done great work porting and editing assets. Many of Super Mario 64's original assets have required extensive changes to be suitable for use on the GBA, and so that help is massively appreciated, and the project definitely wouldn't be as far along as it is without their help. That's about all for now. Thank you for the supportive comments, and I'll see you in another video.